is our sun. You might say, pretty cool. Most of the mass and energy in our little solar system is right there. Ever worried about it? That's it. And yet our sun is small, small potatoes as stars go. And the astrophysicists count our suns in the multi-billions of little, brown dwarfs floating around. But it's really exciting. We now have an eyehole on the sun from a set of satellites we've launched in just the last few years. One called the Solar Dynamics Observatory. They can track the giant solar storms. You might say, why do I care about giant solar storms? Well, you should care, because these storms erupt at millions of kilometers an hour. They stream protons and other things to the Earth. Our fantastic force field, our magnetic field, protects us in part. But some of that energy gets into the Earth's orbit, and what does that do? It affects the GPS satellites we use to drive around when we're in traffic jams. It affects the power grids. They feel the effect of the currents from these storms. Our satellites are up there, and they're naked in the breeze. They're not in the geomagnetic field. And so many times they shut down. So we watch the sun in 3D for all its splendor here with this satellite, as well as a pair of satellites in the stereo and a bunch of others, as part of a program to live with our star. We call it living with a star, not originally. But this is an exciting world, and we really are just beginning to peel the onion on how that star works. And you might say, why do we need to do that? Because the sun puts so much energy into the Earth system that helps regulate climate. It affects how we live. And so we do need to worry about our parent star just to live well on Earth. And if the sun all of a sudden shrinks, the planet will get colder, blah, blah, blah. And if it goes supernovae, well, the Earth will turn into a cinder, and that's a ways off. So no worries. No 2012 here. Next slide. All right. So, and then there is our little neighboring planetoid, the moon. What's interesting about the moon? The moon is a fossil planet. And when we look at it, we say boring, gray, and then we see these things. The realization that these cosmic collisions, measured in millions to billions of megatons of TNT of energy every time they collide, is the same record we have here on Earth, but we don't see it. So every day our planet is pummeled by debris from space. And every so often, big debris produces giant stars, almost the size, in this case, of Texas, and those stars tell us of the history of our planet. The next slide will show what the moon looks like in 3D, because for the last year, here it is, these colors represent highs in yellows and whites and lows in blue. This giant hole, about the size of Australia, the south pole of the moon, was not visible in photographs. But our lunar reconnaissance orbiter has allowed us to look at the lay of the land, and all of these craters, these cosmic stars, are the same population of stuff that hit our Earth. As Stephen Jay Gould said 20 years ago, I know he's an active fan, for those of you who may not, but Stephen said it best. If it weren't for these collisions that made all these scars, we would not have the life on Earth that we have today. Cosmic collisions have changed the history of biology on Earth, and we see them on the moon and we study them. Next slide. My last couple minutes, I want to quickly take you on a tour of Mars, because I had a dream when I came to NASA to study Mars in 3D, and we did. This map, shown in color, the giant volcanoes of Mars and the plains we think now are related to the history of water. This map, and here's the crater of Gusev, where the Spirit rover's been wandering for 3,000 days. This map in 3D is good to a few feet. It allows us to find landing regions on Mars. It also shows us the fact that the northern lowlands and these other big holes are interesting places where the history of water is lurking. The next slide will show Mars taking that map and displaying all the beautiful photography we found of the planet from our Mars exploration program. And you can see giant volcanoes. Hawaii would fit here. The United States would fit here to scale. Another big volcano. This mission, the Mars Science Lab, the Curiosity rover, is our next foray into asking, could life ever exist on Mars? And so MSL here, including an instrument built right here at Goddard, known as the SAM instrument, will be looking for the building blocks of life on Mars, not in a parking lot, but in the most exciting possible place we can go. This rover stands as big as a Mini Cooper, and it includes a vision system here inspired by the movies of James Cameron. Happens to be a co-investigator. So we expect to take wide field stereo zoom imaging of the surface of Mars. So instead of driving around always looking, well, I guess I can see you. Imagine me zooming in 10x with you wide field and then zooming out the way when Mr. Cameron's made his spectacular movies. We'll have that for this mission. But we expect to understand biological potential of Mars by roving around for tens of kilometers with this mission, starting in the summer of 2012. It will be the most exciting mission to Mars in the history of women and men. And so we're ready to go. Next slide. Last couple. Don't forget our sister planet Venus, who looks rather nasty until you unveil her secrets from these views from the Soviet landers and this radar map in the background. We can do better at Venus, because on Mars we have a cold, dry planet, outbound from Earth, and inside the orbit of the Earth we have the planet Venus, our sister planet, and our sum total of understanding of the surface is moderate resolution radar and a few photographs from the Soviet Union. See, SSR in Russian. They landed on Venus. Why do we care about Venus? Because its climate went nuts. A planet that could have been like Earth ended up being the virtual greenhouse of all time, 450 degrees centigrade at the surface. Climate change on that planet affected it. Will that ever affect Earth? Next slide. So we wanted to get to know Venus. And finally, we also want to get to know the now no longer classified as planets, objects in our solar system, Pluto. This is the New Horizons spacecraft halfway to Pluto. This is a 12-foot antenna. And instruments here will take Pluto out of the realm of this, kind of looks like a laser dance ball that you have at a party, and put it into the realm of actually seeing how that planetary work, that dwarf planet. We haven't ever been there. First human flyby of that world will occur in 2015 as part of this spacecraft built here in Maryland at the Applied Physics Lab with instruments from around the world. Next slide. So I'll finish with a couple of thoughts. One is, we better be wary of what happens in the universe, because in the solar system here, these funny-looking smudges on Jupiter, many times larger than the Earth. The Earth would be about this size relative to Jupiter. These smudges are signs of cometary cosmic collisions. They happen all the time. In the last 15 years, we've seen two big ones through the eyes of Hubble Space Telescope. Look at these scars. They're scars in the atmosphere bigger than the Earth on Jupiter. This is going to happen. Hence the interest in studying near-Earth objects and actually going to visit them. One of NASA's future plans is maybe to send one of you to an asteroid, because they will hit Earth. It's just a question of when. Next slide. Finally is the deep universe. The Hubble Space Telescope and its soon-to-be launched in the next few years, James Webb, have shown us that the universe we thought we saw at the scale of a pinhole of light is full of stuff that we didn't even realize was there. This is the only star in all these pictures. And all these other smudges are galaxies. There are 10 to the 26 or more objects we've now cataloged in the universe sky, if you will, through Hubble and other telescopes. What we realize is a lot of this black stuff, this empty space, isn't empty. It's the dark matter and dark energy glue that holds all the rest of the stuff, including us, together. So it's a big universe. It's really exciting. Let me finish with the last slide over. We're lucky we're studying here from our satellites and our human exploration program. And I leave you with the view of the Earth at night, sort of a way of recognizing that we're here. You know, if you're flying on the Starship, whatever. You probably could see the lights of Earth and the biology of the oceans. But Western Europe, North America, the lights kind of show where people live. Notice a lot of them live along the coasts. So a few foot of sea level rise might actually matter. People in Venice might be a little nervous, and as they've been for hundreds of years. So our planet's a wonderful place. It's the cradle. But I'll leave you with one last thought. A lot of people say, why care about space? Well, our planet lives in space. So why would we not care about where we live? Because how our planet goes is reflected on what space does to our planet. Whether it be the sun, cosmic collisions, the empty space that is the dark matter and dark energy that connects our universe together and holds it together. That's how space works. And we've used space to study our world and others very effectively for the first 51 years of NASA. I think the next 50 will be better. Thanks.
Awesome.